We are Team Time Hacker, and here are our group members: Cenyi, Wuhan, Liu, Qinkai, and Bingjie. Firstly, let me give a very brief introduction to this project. COVID-19 is one of the biggest challenges in human history, and it not only threats our health, but also influences many other aspects of our life. For example, losing job can easily destroy a family, especially in this pandemic. So, except for predicting new cases and the unemployment rate, we also want to explore if there are any relationship between COVID-19 new cases and unemployment rate through the given data. That's why we divided this project into 3 parts instead of 2. So, okay, let's move into part 1. Our analysis structure is from COVID-19 database, and we use 2 models. And by these 3 selection criteria, we select the best model, and which gives us the final prediction. So for the model we used, I think everyone is familiar with the ARIMA. So just mention a little about the HOTS model. Basically, it is a tool in time series using exponential window function. And for the model selection criteria we used, actually there are more criteria available in the system, but we chose below 3, which is the root mean square error, mean absolute error, and the mean absolute scale error. Okay, next part, let my partner Wuhan to introduce the detailed data.
Okay, now let's look at the trend of the confirmed cases of 3 countries. We can find that all the countries experience a trend of a rapidly increase and then level off because of the difference of the population and the control policy of different countries. The daily cases differs, and some countries, like the USA, have several ups and downs. Then our group try to handle the data of different countries to train the model with ARIMA and HOTS. We can find that the data is not stationary. So for the ARIMA, we difference the data, and all the difference data pass the ADF test and the box test. So we use the different training data to fit the best ARIMA model, and then we use the best ARIMA model to predict the cases of the following months. To accurate the result, we only use the training data to predict the next month. For the HOTS, we use the hot winters function to train the training data and then make the prediction. When it comes to the model selection, we found that for the UK, all the index use that ARIMA is better, so we choose ARIMA to predict the case of the following months. For Singapore, we found that MSE shows that ARIMA works better, but MAE and MASE shows that the HOTS is better. And for the US, the situation is the opposite. So we try to use the average of the final prediction. So the following part will be lectured by the next student, Qinkai.
The second part is our analysis of unemployment rate. Firstly, for Singapore, the data is non-stationary, and then by AIC criteria, auto-ARIMA function give us ARIMA 0 to 1. And after portfolio test, we can tell this model is adequate enough to fit the regional data. And then the prediction values are shown in the chart, and RMSE is about 0.117. From the plot, we can see our prediction corresponds to the overall trend in the recent months. Then for the United Kingdom, auto-ARIMA function gives us ARIMA 0 to 0. It seems that there's no information that we can use to make prediction. So we try to include some exogenous variables to improve it. Here we use the log value of the 4 indices like government response index, containment health index, and etc. And as a transmission of policy may have some lag effect, we used 1 period lag value of the covariate and add it to the right-hand side of the ARIMA function. And that is how we get a RIMAX model. After trials of different sets of index, we finally get the best one with ARIMA 110 and containment health index, but the forecast seems not that good. So we further compare RIMAX with several other adequate ARIMA models. According to the prediction root mean square error, we eventually selected ARIMA 0 to 1. And here's our forecast. As we can see, the forecast is much better than the former model. And then it's a prediction for the United States.
For the prediction of the unemployment rate in the United States, the final model is a Riemann model, and the model parameters are 1, 3, 1. According to the graphs and the corresponding tests, we found that the original data is stationary without the difference. Then we used the auto-dark Riemann by the BIC criterion. The fitting result are 100, but the RMSE is 1.774. So the effect of this model is not good. Then we took the logarithm of the data and the refitting. The RMSE is 0.7758, which is a big improvement. Furthermore, we took the impact factors into consideration and we tried the VAR model, a Remax model, and the profit model as well, but the results were poor. So I won't go into any details here. Considering that the unemployment rate data in the United States has the following characteristics. For example, the data volume is more, there is irregular data trend, and there are several sudden changes. So we have carried out cubic interpolation on the data according to the changing trend of the original. The interpolated daily frequency data shows that after the third order difference, the data becomes stationary. And from the ACF and PACF, we finally picked parameters as 1, 3, 1. The RMSE fitted by this model is 0.1599, which is a great improvement over the previous models. Then we visualize the residue items of the model and performed a box test. The fit of this model is also good. Therefore, for the unemployment rate data in the United States, the Riemann model is finally selected and the order is 1, 3, 1. The predicted result in October is 4.37. The following is the part 3 by Bingjie.
Okay, for this part 3, we will further explore the two variables relationship. Let's first look at the descriptive statistics of the two time series in 3 countries. For example, Singapore, when there is an increase in the new cases, then there would be an increase in the unemployment rate, so as the UK and the US. So we guess there could be some lead-lag relationship between the two series, and we could find some maybe co-integrating factors to showing the similar trend. Then we will test our guess for Singapore. We follow the procedures taught in our class. The Johansen test says there could be one co-integrating vector, and we write it there. Then we will construct our VEC model like this. We use this model to predict the unemployment rate during the validation period from June to September, and it shows great. The prediction value is near to the true value. Then we give further prediction for November and October. For United Kingdom, however, the Johansen test rejects our null hypothesis, and there are no co-integration vectors, so we will skip this part. As for United States, we follow the similar procedure and give one co-integrating vector written as this. Then we will also construct the VEC model like this. However, the prediction value is somehow not desirable because it's kind of far from the true value. So we could choose the formal model introduced the previous part by my teammate. So after introducing all our models, we have some further thoughts. First is the original data. Actually, for the new cases prediction, we only have daily data. However, there could be some fluctuation influence. Maybe we can transform our daily data to weekly data. Then for the unemployment rate, the sample size is too small for us since we only have monthly data. For the prediction tools, actually we only use some commonly used models, but there could be other models like the neural network model we could use to improve our improve our model performance. And there also are some other factors that we don't discovered that could affect the unemployment rate and the new cases. So that could be what we should do to improve in the future. So that's all for our presentation. Thank you for your listening.